Hello and welcome to our weekly Geek Out. My name is John and I'm the science educator for Children's Museum Houston. And we are in our exhibit, How Does It Work? We're not actually at our science station like we usually are every Tuesday. Now this week we're gonna tackle a pretty simple question to ask, but a difficult one to investigate, and that is, what is gravity? Gravity has been studied for hundreds of years, and Sir Isaac Newton described it as a mysterious action off in a distance. And then later, Albert Einstein described it as a bend in space and time. Well, what does that even mean? I mean, we experience gravity every single day, and we can think of it as, well, it keeps us on planet Earth, and it keeps our planet orbiting the sun and all the other objects in outer space orbiting the larger objects in their solar systems. But what we're going to do is we're going to do three pretty simple experiments. But in order to do that, what you'll need is a jug of water and a Ziploc bag. But I think we need to switch spots. Much better. Now we can do our experiments from all the way up here. Now, if you're following along at home, you don't have to be on a second floor to do these drop tests. If you are going to try and follow exactly what we're doing, please make sure to have parental supervision. You have to have an adult if you're going up to a higher location to do these drop tests. Because science is a lot of fun, but it can be dangerous. But if you don't go up to the second floor, that's great, because you can do it just from the ground where you're standing right now by just sticking your arms straight out. Because the big thing you have to do for this experiment is drop at the same exact height and time. So what we're going to use is a Ziploc bag and a golf ball, and we're going to see which one makes it to the ground first. Let's see. 3, 2, 1. So our golf ball actually made it all the way to the ground at least 2 or 3 times before our Ziploc bag made it. Now, why did that happen? Well, maybe you would think because the golf ball's heavier. That's true. What if I told you something like air resistance was impacting our experiment? Well, in order to kind of demonstrate that, I'm going to use 2 objects that are the same shape, but one is much heavier than the other. This liter jug is half filled, so I have a half liter of water, and then I have an empty bottle on this side. So we're going to do the same thing, but we're going to drop it right now. In 3, 2, 1. And just like that, they actually hit at the same time, because the air resistance that both bottles are experiencing is about the same compared to the golf ball and the Ziploc bag, which the air resistance is not the same. So what is air resistance? Well, that's all the air molecules that are impacting the objects that were flying through our air. And the Ziploc bag is just being caught up in the air resistance. So we can try one more test, but this one involves a very heavy object. We're going to use a cannonball, and then we're also going to use a pink little plastic ball. And we're going to do a drop test that is actually very similar to Galileo, where he dropped 2 spheres of different weights from the Leaning Tower of Pisa. And so what we're going to do is we're going to drop them at the same time, and we're going to see if they land at the same time. In 3, 2, 1. And if I released it at the same exact time, even though they're different weights, gravity acts on them the same because we're on planet Earth, 9.8 meters per second squared. So now we have a final experiment we're going to try, but I actually have to switch locations again. Now that we've explored gravity on our planet, what we want to do is look out into outer space. And to do that, we're going to use this black stretchy elastic here, because gravity is dependent on the mass of an object and the distance between them. Because every object with mass has some type of gravity associated with it. So if you have a heavier object like a ball bearing or a cannonball or a bowling ball, that's going to have more of a gravitational effect in our space-time continuum than a ping pong ball, and we can demonstrate that. So if we place the heavier sphere in the center, you can see kind of a warping effect. And we're going to use some lighter spheres, marbles, golf ball, bouncy ball, and we're going to start orbiting this heavier object. So we can picture this as maybe a star or a black hole even, that has a much larger gravitational pull than something like a planet or an asteroid. So if you're following along at home, you can actually do this even with just a sheet, as long as you pull it nice and tight over top, or on a trampoline. You could do a really big demonstration with a trampoline. So once you have your larger object in the center, all you'll do is you'll start to rotate these objects around. You can even go the other way, see if we get a collision. And so as they're going around, the friction of the fabric is starting to slow them down, but it's orbiting the larger object that is in the middle. So if you put a lighter object like a golf ball, you can see that there's not quite as strong of a gravitational pull that the heavier cannonball had. You can even do one that's a little heavier and see that there's a little more of gravitational pull, especially when they come closer. You can see it kind of speed up and move across. And so now we've not only explored gravity on our planet, but we've explored gravity outside of planet Earth to explore how objects like asteroids and planets and stars and even black holes operate using gravity. So I hope you guys enjoyed this week's Geek Out. If you guys have any other questions that you want us to investigate, please send us an email at geeks@cmhouston.org. Those emails will go to me, and then we can whip up a cool Geek Out for a future week. Again, my name is John, coming to you from Children's Museum Houston, and we'll see you on the next Geek Out.